My name is Alexander Johnson. I'm the Azure SRE Program Manager within the Service Fabric product group.
My name is Mikkel, and I'm also part of the Service Fabric program management team.
We're here to talk to you about best practices with Azure Service Fabric. As a best practice talk for an open source platform, we provide this content publicly. We understand it may be challenging to keep up with all of our accessible content, such as 1,000+ pages of markdown documentation that you can find online today, which would include a production best practices checklist and cluster security best practices documentation, which I'll be diving into more depth later on in this talk. Just go down a little bit.
Sure.
In order to be successful with Service Fabric, we're going to walk through 6 specific topics: deployment automation, cluster security, working with state, capacity and scaling, patch management, and telemetry and monitoring. What we're going to show you is how to make your life easier based on user experiences. During the talk, we will show you both existing and new features to help you achieve success.
There's a bit of a feedback on the mic. Are you good?
So again, this is the journey that we're going to take you on today, walking you through all the activities and actions you need to take to be successful.
Yeah, so let's start talking a bit about the deployment automation. And I think we got a slide about this. So when we talk about deployment automation, we really talk about 2 things. First of all, you have your cluster, you have your infrastructure as code you need to take care of. It's about the process of managing, provisioning the infrastructure through files, and rather than having to run PowerShell commands or CLI commands against your cluster. We're also going to talk or show you a little bit about how to continue to deliver your application updates. So using a thing like Azure DevOps. So how many of you, let's just get this right. How many of you are running Service Fabric clusters in production today? Fair amount. How many of you are using Azure DevOps or a similar CI tool? How many of you are using that for your clusters, configurations, ARM deployments? Fewer people. For application deployments? A lot more people. Okay. So we definitely want to, encourage you to start getting into the habit of having even your cluster configuration run through a CI pipeline. And I'm just going to show you a little bit of how Azure DevOps can help you do this and and some of the features we actually build into Azure DevOps to help you succeed with this from an app point of view and also cluster point of view. I think I'm on 7. Let me get over here. Cool. Are you okay with resolution? So I'm in the Azure DevOps, or formerly known as Visual Studio Team Services. And you can see I both checked in my cluster template and my cluster parameters into my source control. And it's very easy for me to use these ARM deployments through the pipelines that I can set up and configure inside Azure DevOps. When configuring pipelines inside Azure DevOps, I have the opportunity to define the artifacts that I want to deploy with and different triggers that can trigger a deployment. I can do this automatically, I can do it manually. And I can have my deployments and cluster configurations go through the different stages. Let's say in typical situations, I might have a staging cluster and might even also have a production cluster, or might have more of these stages that I want to deploy my application through. I get to define different gates for when a deployment should start. So gates are basically a way of adding some automated functionality to go and react either to check a health of a deployment or check for some check for certain conditions that need to be in place before I go and start a deployment to a cluster. And I can invoke Azure Functions or REST APIs or any logic I want to build in here. I can also do specific approvals. I can appoint people that need to go and approve as things move forward and progress through the stages of a deployment. So this is all very good and helpful, and this all both applies to pipelines that are built for cluster configuration and even app deployment. For cluster deployment and configurations inside Azure, doing this through ARM, there's a simple task in Azure DevOps, which is called the deployment, an Azure deployment, a resource group deployment, which basically hooks you up with an Azure subscription, create or update your resource group, and takes in the template file that I just showed that I checked into source code. So in my scenario, for instance, I have this first piece of my pipeline that's going to use one parameter file. So I have a specific set of parameters for my staging environment. That could be the number of nodes I want to run. It could be the SKU of the nodes. I might want to run smaller nodes in my staging environment to just reduce some of the costs that I have. And there's also good integration for things like secrets, admin passwords I need to set for my cluster. And I can even use a feature in DevOps such as defining variables, have them stored securely inside DevOps. Or in the case where I have, for compliance reasons, I need to manually enter these at deployment times, I can do that and make sure I can only do manual deployments, and I can type in the passwords at that point in time if I need to have them stored in some other system that Azure DevOps. So we definitely encourage you to go ahead and do this and make sure that you get your cluster configuration set up in this way. Now, the other part of this is from the application point of view. So I just want to quickly show you. I have an application here. And let me go over to I have a Service Fabric cluster as well. I have a cluster here running with no applications on, tons of nodes. It's funny when you need to do demos. And let me just go back into Visual Studio. I have a simple web API. I just need to do a little bit of change, and I'm going to tell you why. I can go and push this change to commit. Just do code update. Commit all of these, and I just need to go over here to do my sync. So now that I pushed my update from my local repo and out into Azure DevOps, we'll soon see the build kick off here. Now, as part of Azure DevOps, we also created a set of tasks specifically for Service Fabric. So if you need to go and build service or set up build definitions for Service Fabric applications in Azure DevOps, there's actually a build definition template, as it's called. Let me go back once, and I think we could do a new, and I can just show you how it looks. So if I wanted to set up a new build pipeline, I just point out my repo. Oops. And you can see we have an Azure Service Fabric application, which is basically a combination of tasks that's predefined and configured in a way so that you can easily deploy your Service Fabric applications. So a few things I want to call out in here. There's some NuGet restore, there's some solution build, there's in the Service Fabric project build, if you're familiar with those, where we go ahead and we go and package the application packages as part of the build process. What we're also doing is we have this specific task to help you control versioning of your applications. So as you're all well aware of, those of you who use Service Fabric today, whenever you go and deploy an application package, there's sort of this structure of versions within the application packages, where each and every component in there is versioned, and it gives you this great ability to independently update even code and config of the individual service packages and so on and so forth. What this task is doing inside VSTS is basically go and comparing the build that's just been run with a previous build and automatically updating the version of the individual elements within the code package that changed. So let's say the change that I just did, where I changed a single file inside my web API. Now it will actually go and figure out that code package specifically was changed. It will rev the version of my code package. It will leave my config package the same version as it was before. So when it goes and do a deployment into the cluster, only that code package is the one that's going to get updated. So some nice features that are already there in VSTS. We do have similar integration with I know Octopus Deploy have done some integration. Jenkins as well is an option for you to go ahead and use. So for this specific deployment pipeline for my application, now this is the deployment pipeline for my application that I'm showing. I showed the one for the cluster before. I just want to call out this one thing. Again, we have tasks for go ahead and deploy the application. We help you set up cluster configuration. You can define, use the Visual Studio concepts of publish profiles and parameters. You can override them in the pipeline, and you can configure individual upgrade settings for the different pipelines that you have. Like for instance, since this is demo and things need to go a little bit fast, I'm just doing unmonitored auto, and Chaco is looking at me now saying, don't always do monitored in production. This is just the demo. But you get to configure your upgrade settings and everything directly inside the pipeline. There's full support for these things. What we also have is this task for running PowerShell scripts. So any PowerShell scripts or commands you want to run against your cluster. What's very convenient about this is that we make sure to set up the cluster connectivity. So you basically get a PowerShell, not a PowerPoint, a PowerShell session that is already authenticated against your cluster management endpoint, and you can run the scripts you want. Now, the reason why I'm doing it in this deployment is because I want to draw attention to another best practice that we really want to tell you guys about, make sure that we reiterate. As you see in my application manifest here, I'm actually not using default services. You see typically with inside Visual Studio, when we create a new Service Fabric application, you get these default services. Those are very convenient. Those are also very convenient for Visual Studio because it's easy to start up your services and start while you're debugging. The problem with using default services that we see some customers run into sort of down the road is that you start mixing the concept of So an application manifest is basically a type definition, right? When you go and register these application manifests inside of the Service Fabric cluster, you register an application type. You can create multiple instances of those. And the same way, once you have the application up and running, the service types that you define inside the application manifest, you can create one or more instances of those, and they can all run with different configurations. Now, when you go and declare default services inside the application manifest, you actually specify a fixed set of instance configurations you want to run with. So you sort of go and mix this instance and type concept we have in Service Fabric. And there are things you can do once you have these default services up and running. There are basically settings you cannot change and parameters you cannot change. Like you can't change the instance number of this application you want to run. You can't change that through an upgrade. That will basically fail. So there is a way for you to enable default service upgrade, but it's a very dangerous path because you can end up deleting service unintentionally, and that's not a good way. So what we rather want you to do is actually see if you can get out of the habit of using default services, those of you that do that. So two things you then want to do is once you get this application up and running, and that's what I have over here in my pipeline, is I run a simple script to basically check whether the service is up and running or not. If it's up and running, I go and update the service. I think I have the script here somewhere. I'll basically go and update the service, and you can see I can pass in all my parameters for the instance counts and placement policies and things I want to run with. It's telling me I need to zoom. Okay, Deep is doing things like that in the back. Let me try and zoom this. Okay, there you go. And you can see that I'm just creating a new Service Fabric service if the service is not up and running. So it really gives me full flexibility, and I can change the configuration of my instances even post-deployment. So going back to, and let me call out the last thing. I just talked about how Visual Studio relies on default services for debugging. There is a thing which I think is still an undocumented feature, and we need to go and fix that. But in this scripts folder you have in Visual Studio, you can actually set up a start services.ps script, and Visual Studio would pick that up for your debugging scenario. So there's a way to also solve that for you. So we should see now that my application is now deployed. I have my app up and running, and I even have the service created that was run through the script, and all the configurations that I defined for my service. So let's switch back to the presentation. So, get all this automation up and running. There's a lot of stuff that's out there in Azure DevOps specifically, that service, to help make this really easy. Make sure that all these repeatable tasks just become very easy, propagating changes through stages, and application deployments and upgrades as well is going to be a breeze for you.
My favorite topic, security. The next topic we're going to get into is cluster security. Specifically, 3 things I want you to take away from this talk is automate certificate rollover by using common name, use AAD for client authentication, and do not use self-signed certificates in production. Using certificate thumbprint and prevents you from auto-rotating your certificate because you cannot identify multiple certificates with those properties. They are uniquely penned to that certificate, which means every time you need to change them or roll them over, you increase the reliability risk of your service. So before we go further into this, I want to talk about the security scenarios. So in Service Fabric, the areas that we're trying to address here is that node-to-node communication, that client-to-node communication, application communication, and role-based access control. So node-to-node communication is the system processes on one machine communicating to another machine, on another process on another machine. Client-to-node communication is a Service Fabric user communicating to a Service Fabric process on a machine. And application communication is your service-specific communication, your implementation-specific communication. And role-based access control is the limiting of access to Service Fabric management endpoints to a particular group of users. And in Service Fabric, there are only 2 types of roles: admins and users. Admins have read-write capabilities. Users only have read capabilities. So a best practice for securing this communication is to use X509 certificates. And in Service Fabric, there's only 4 types of certificates: service certificates, cluster certificates, client certificates, and your application certificates. A service certificate is used to secure the management endpoints. A cluster certificate is used to secure the encrypted communications between nodes. The client certificate is used to identify the users of Service Fabric management endpoints. Most commonly used to connect to SFX or Service Fabric Explorer. Again, the best practice here for client certificates is to actually not use them and eliminate that secret in the management lifecycle of that and use Azure Active Directory. All these certificates, again, can be identified by their thumbprint. But if you identify them by their thumbprint, you must update them, again, increasing the risk of reliability for your service. A better practice is to use a certificate authority's issuer thumbprint and its common name of that certificate. This allows secure identification of multiple certificates that both be valid as long as they're not expired, which means now we can auto-rotate them through a discovery mechanism. Again, of all of the aforementioned certificates, the only ones today that you cannot do common name, which is coming in a roadmap, is your application-specific certificates. You are bound to a thumbprint today. So again, the key takeaway on this portion of the talk is that you should be using common name and issuer thumbprint to auto-rotate your certificates. You're eliminating the repetitive tasks of updating those thumbprints in your manifests. And you can now automate it, eliminating that operational task, eliminating that risk from your service. The other thing is, using AAD eliminates that certificate at all for client identity. And not using self-signed certificates in production allows you to do common name and issuer thumbprint and support auto-rotation. Too far. So the main point of how this all worked, or how it came together, is that we had to implement some changes to the platform to now use the certificate that expires furthest in the future, so that we can pick up that certificate and use it for your application, for your cluster, for your client, any of the system services certificates. However, the complete end-to-end secrets lifecycle management for Service Fabric certificates requires a complementary service called Azure Key Vault. When a certificate, or when a Key Vault certificate is created, you create it with a policy. This policy informs Key Vault on how to create the current version and the next version of your certificate. A certificate policy that you create for Key Vault contains specifically 6 types of properties: X509 properties, key properties, secret properties, lifetime actions, issuer, and policy attributes. Let's see if I can switch over.
It's 7. It's the next one, yeah. Here.
Up here on our screen, I have a Key Vault using Portal. Here's a few certificates being used by a cluster today. When I go through this workflow to create the certificate, a policy will be created. There's only one policy for every Key Vault. Specifically, I need to drop down and select which CA I'm going to be using, and that will be the issuer thumbprint that I need to declare in my template. I also need to provide a common name, and it should be the name of your cluster, like so. With that type of certificate in place, with that type of certificate, now I can auto-rotate that certificate for you. Of course, setting up rules means that the next time the certificate will expire, Key Vault will generate the next one, or send that CSR off to your CA and generate a certificate in Key Vault for you, and then that can be deployed by a vMix extension onto your nodes and auto-rotated, without you having to change anything in your application. So why do you want to do this? Of course, this now enables you to support best practices of changing your certificates frequently. But more importantly, as of March 2018, vendors of browsers and certificate authorities got together and voted to change the duration, max duration of certificates from 3 years down to 2 years. This trend of making it more and more frequent, we believe is going to continue, adding more and more risks to those who are not using common name and issue or thumbprint, because they're going to have to change it more frequently. So now we're going to pass it on to working with state.
So let's talk a little bit about working with state inside Service Fabric. How many of you are using reliable collections in Service Fabric today? Some of you. How many of you are doing backups of your reliable collections? None of you? Are you doing backups of your reliable collections? Yes? That is good. Thank you. On your behalf, thank you. So, reliable collections is data you store inside a cluster, right? We know we have the world's most reliable technology in Service Fabric. We also know that you sometimes, when there are too few nodes, the clusters are not big enough, or there's a thunderstorm in the south, the US. There is data inside this cluster, right? There is data on these machines. You need to back it up, unless you have some mechanism for hydrating them, unless you use it more like a temporary data store. There are APIs today in Service Fabric to help you do backup and restore, but you basically have to go and implement it yourself. You even have to implement things as looking into events when the replicas know that they're in data loss situations, for them to go and pick up restores. Now, what we built for you is we actually built a backup and restore service for automation. It's been out there in preview for a while now. We're getting closer to GA8. I just want to show you how you can use the backup and restore service and how that works, and how it really makes it easy for you to start doing those backups of your reliable collections. So let me go back into a few things that I have. Okay, we're back. Cool. So here's another Service Fabric cluster. And you can see I have a few applications in here. I have a demo applications and I have web reference applications. Now, demo application consists of a bunch of different kinds of services. You can see I have stateful services in here, and you can see that, but believe me, just based on the name here, that there are actually actors as well. So there are actors, persisting state, and there are stateful services, persisting state in here. So for the purpose of this demo, the other thing I want to show you is that by using enabling the add-on feature of just enabling backup and restore service, we actually go and deploy the backup and restore service as a system service inside your cluster. And this is where it all becomes interesting. So you don't, apart from just enabling the service, you don't have to do any configuration, so on. You just now have the infrastructure pieces in place so you can start doing your backup. Well, then how am I going to do my backup? Well, I'm glad you asked. Let me show you. So for this, I'm just going to use a Postman for now. You only have the REST APIs that I can go and do this with. We will provide PowerShell commandlets for your convenience at a later point in time. But basically, the way that this works is you have a concept of backup policies. So what I'm going to do to begin with is I'm basically going to call into my management endpoint. I'm going to call the backup and restore service, and I'm going to get the backup policies that are there. So let me just fire this one off. And you can see there's a few backup policies defined. Let's just take a look at what those are. So there are concepts in here like being able to do auto restore on data loss. So data loss is an event that your reliable collections will get if they go out of quorum. If a petition goes out of quorum, the on data loss event will be raised, and it was sort of today, it's up to you to go and implement a way of enabling or triggering the restore when these events happen. If you enable the auto restore on data loss, you don't have to do anything in your code. You can run the code you have today and you will still get the benefits of doing restores when data loss is detected. You can configure things around the backup such as the number of incremental backups you want to keep, if it's frequency-based or if it's a trigger-based backup, how often we're going to do backup. In this case, we're going to do backup every 15 minutes. So backups are being stored inside a file share, so you need to provide a file location for this. From running in Azure, you can do Azure Blob Storage. You could probably even do blob storage from on-prem if you would like to, but we also support just a regular file, say UNC file share. And finally, there's some retention policy you can add to that. So you can deploy one or more, describe one or more backup policies and deploy them into your cluster. They're there. And then what you need to do next is you need to go and assign the backup policy into the things you want to back up. So you can assign backup policies for applications, for individual services, and even for individual petitions. So it can become very messy, but it could also become fairly easy. So if you define a backup policy and attach it to the application level, all services and partition underneath that application will actually run by that backup policy, but you can do overrides as well. So you know how sort of a hierarchical inheritance concept, I guess we could call it. So what I'm going to do now is I'm just going to go and get the backup policies or the backup configurations that are assigned to my specific application. So in this case, I'm going to call into the web reference application that I have, and we can go and look at the backup policy already configured. So there's a backup policy configured. We can go back and look at that. We can see it's inherited from application because this itself is an application. So we can also go ahead and see the kind of backups that we already have from the application. If this request comes back pretty soon. So you can see there's a long list of backup already been taken, and you can see you have information as you have a backup ID application, the services that was backed up, the backup location on file, and all this goodness. So let's go over to the web reference application. This is the fun part of the demo. So in this application, I actually just have this one partition that I've done backup of. So there's one stateful partition in here. We've done a backup of that. Now we can even go over and see the application itself. So this is basically just, it's an application mimicking I think it's an inventory sales thing. Anyways, there are numbers in here. Let's try and reset those. So all the data that you see is actually stored inside a reliable collection in the service that I just showed you. And there's a nice feature called corrupt data in this application. You probably don't want to go implement that yourself. But let's try this out and see if it works. Let me just try and refresh this guy. So let me corrupt the data. The size says, but I'm pretty sure if I now go back and reset, everything's gone. Availability is down at 0. Oh no. I'm glad we had a backup. Okay, so let's go back and look at the partition backup list. So now I'm specifically going querying that partition that I want to go ahead and restore. So you see I put the partition ID up here. Let's send this one over. I'm going to go pick the backup that I want to restore. So I can go down the list, and I should have the latest backup down here. So I need the ID, and I need the backup location. This is where it's all going to be interesting. So let me go over to the restore partition. Let me put in the ID. Let me go back to the partition list. I'm going to get the backup location. So it's basically just a zip file. I can go in. Add that in here, and I'm going to miss a. Okay, so basically put in the backup ID, put in the backup location. I'm going to post that back to start the restore. We see it's accepted. I can go and get the progress. You can see right now it's just accepted. Hasn't started running yet. Let's go back. See restore is now in progress. So basically what's happening now is the restore service is going off to the file location in Azure Storage. I'm going to pick that zip file, and it's going to restore my, my partition. We have success. Let's see the web app. Hey, and there you go. We have all the data back. Cool. Is it good? Yeah. So no code changes to reliable collections, to stateful services, or your actors. Using the backup restore service, you have this full backup restore thing that you can now work with. You can recover from unintentional or intentional data loss, corruption, like we did here. Yeah. So capacity and scaling, Alex.
Yes. So the first thing I want to talk about is the minimum number of infrastructure virtual machines that you need to have. This tends to be sometimes a confusing topic for especially new adopters of Service Fabric. So in production, you need to have 5 machines minimum. And you can scale your application because most dynamic cloud services do not stay at just 5. They need to scale up and down. And you can do that in a manual programmatic way. So as you ask, why 5 and not 3? So Service Fabric applications need to be deployed across fault domains and upgrade domains. These are the isolated units, racks and hardware and power supplies to ensure that if one of those things were to fail, it doesn't cause a catastrophic failure across your cluster. And this allows you to have ability to support quorum, and that means you have to have a majority of your replicas available. In math terms, this is really n divided by 2 plus 1, which minimally means you have to have 5. again, in production for Service Fabric applications, you need to have 5 machines. And you can scale your applications programmatically or manually by adding a VM to a scale set. Now, this is really using a compute SDK, and in-service calls can call those methods to scale out. You could also scale by adding a virtual machine scale set to your cluster. And certainly at a certain size, you should absolutely have multiple scale set types, multiple VM scale set types, so that way each workload can be profiled down to a particular type of machine set. A scale set is an OS, it's a SKU, has certain ports opened. These things should be specific to workload types when you have a certain amount of them. Another thing to be aware of for Service Fabric applications that sometimes runs into confusion is that you can scale a scale set to 1,000 VMs today. But for Service Fabric applications, we need to pay attention to fault domains and upgrade domains. In practical terms, it means you really can go to 100 VMs per scale set for Service Fabric applications, and then add more scale sets to meet your demand. So the key takeaway here is that you can scale your infrastructure programmatically and manually. You can do an ARM put, change the amount of instances you need. You can use an Azure CLI. You can use PowerShell. You can change a template, and this will result in more VMs showing up. You could also change and scale by adding more scale sets. Now, why, of course, do we do this? Again, machines and demand are going to be dynamic throughout the lifetime of your application, and you want to be efficient with the resources that you have to drive optimized business value. And when you do a spin-up, or when you scale out, some other key notes that I want you to take away from this is that it's not the by query per second scaling response time. You need to have some lead time for that scaling capacity to be available to you. It's not just boots, there's physics involved. The power of the machine has to turn on, it needs to be available. But more than that, we have to now walk this change upgrade domain by upgrade domain, joining that machine to the federation ring, starting up your services. So when you're doing capacity planning, plan accordingly. Having the expectation set accordingly. So now we're going to talk about service scaling, which is something Mikkel can get into.
So now that Ag took care of adding a few more VMs to our Service Fabric cluster, we can also work with the resources within inside the cluster that are available for the different services we run. And there are 2 things we want to call attention to. First, one is the way that you can govern resources, that services, being it containerized or processes you run, the resources that they actually can consume, and also how you can use auto-scaling policies and custom metrics to sort of build your own system in terms of how you define load and how you want to react to those things. So resource governance is a fairly new feature in Service Fabric, but it basically allows you to specify the number of CPU and memory you want to reserve for your service instances, and sort of feed that as an input into the whole cluster load balancing algorithms that we use. So we make sure that we only place replicas of services and containers on nodes that actually have capacity to run them. So resource governance is one thing. The other thing I want to call out and want to show you now is auto-scaling policies, which I think is an even newer feature in Service Fabric. So going back to the application that I deployed to begin with, the scalable web API. It can scale. Let's try and work with that and see how we implemented some of the custom load metrics in that and how we implemented auto-scaling policies that can actually work. I think I can actually zoom this guy. Let me do that. There we go. So what I've done inside this fairly simple web API, and this is what you can do in any stateless and stateful service inside Service Fabric. You can use the reliable services APIs and report the load from within your code yourself. So if you don't want to rely on CPU or memory consumption, but you want to have other metrics to define loads, such as the number of sessions that you're currently serving from within your service, number of users you're connected to, or number of queues in a queue that's external to you, you can create these load metrics that you basically name and report on yourself. So part of my service definition over here was to set up a load metric that I, for convenience, called load. And then within inside my controller, I can go and report that load. So going back to my application. So what I have here is I have a auto-scaling policy set up on the service instance. So for this service instance, so auto-scaling policy is made up of two things. There are triggers and there are mechanisms. So triggers is basically the ones that are going to monitor the load. And again, it could be CPU and memory. In this case, I'm monitoring my metric that I call load. And I'm doing a method called average partition load. So basically the number of instances that I have, each of them report the load. The average is what's going to be the base of my thresholds. So I have a lower and have an upper threshold for when I'm going to scale. And also have a scale interval that means how often should Service Fabric check and eventually do a scaling of my application. You probably don't want to do 10 seconds. Again, this is good for a demo. It's probably not good for a real-world scenario. The other part of setting up the auto-scaling policy is the partition instance count, which basically means that once I meet my threshold, I'm going to add more instances to this service. And I can either have one, or I can have two running, and I have a scale increment of 1. All of these are things you can configure. So if we go and look at this specific partition, we can see that there's just one instance running right now, right? Because we're running with a load of 0. I think we should be able to see that here. Well, let's go to this instance. So this instance hasn't reported any load, meaning that it's running with a load of 0. We can actually use the metrics view up here if we go far enough to the right. You can see I have my load metric that I put in, and you can see there's no load being reported. So let me go and do this. So for convenience, my web API implemented this method that I can just call, which actually enables me to set the load. So you can see I just got the load from this guy, and there's one instance, and the partition load is 0. So let me go back and call my web API, and let's just add a little bit of load. So let's say let's do 5. So I'm going to send this over to my API. It's going to respond back. I can even go and ask it the partition load that I have. So we can see the partition load is now 5. And you can see in SFX, in the metric view, I can see on this specific node, the metric load reports 5. And I can also see this down on this specific instance that I have. Okay, but the trigger was 10, right? So we need to give it a little bit more. So let's go back here. Let's give it 15. So we're going to send that in. We can go and read out. We now have 15 reported as a partition load on my service. And if we go to the metrics view, you can see this guy now reported 15. And in any matter of second, we should see Fabric now adding another instance of my service, all based on the definition and configuration that I have. I now have 2 instances running because my metric upper threshold was hit. And if I am quick enough, let me just do this in a second, I should actually be able to go ahead and scale this back in again by putting the load back to 0. Let's just get these guys up. Let's report the load back to 0. And if I actually hit the workload 2, you can see it scale in just a second or so. So there you go, it's scaling in, and we should see that the second instance is now going to move, so we're back to just running one instance. So this is a very, very nice feature, again, working with the orchestration of Service Fabric and load balancing and all these features you have inside Service Fabric to dynamically control how many resources and instances of your services that you spin up to help accommodate for the load that is being brought onto your application. Cool. So that was auto-scaling.
What we were able to talk about here is you scale resources vertically or horizontally. Right? You change SKUs with OS specs, different amount of CPU, RAM, storage to make them bigger, or make more instances of them using programmatic or manual methods. This is also available to scale services instances, whether you have more instances using auto-scale, using metrics such as the underlying performance metrics of the machine, or custom metrics such as queue length. So the next subject that we want to talk about is patch management. So automating patch management is an efficient utilization of your human resources. And just announced yesterday, generally available is VMSS image patching. In Azure, this is the best practice. This is the way to where the providers of your OS images will provide the latest patches, and Azure will push them out across the fleet. When you're on-prem, and when you still want to respect upgrade domains, how do you control walking? You can write your own service you like against a repair manager, or you can use our patch orchestration application. We provide this for you. You can deploy this, and we will coordinate. It's very configurable, only 10 particular properties, how frequently you want the patch orchestration application to run, how many retries you'd like to happen if something fails, whether you'd like to have Windows updates only, and of course for Windows specifically, accepting the EULA. We also have 2 versions of POA, of course, one for Linux distributions and one for Windows distributions. Patching is something you can't forget when you own the machines. It is required for all secure solutions. You can't get away with not doing it. You will lose trust if you have a security issue. This is the part of the talk where we're going to talk about telemetry and monitoring. So telemetry is the metrics that you use to measure your SLAs, and monitoring are the rules against those metrics of which you use to measure SLAs. For those who don't know what SLAs are, it's service level agreements that you make with your customers. Internally, you make strategic decisions. Those are service level objectives, the goals that you're trying to push to. When measuring these, you need to measure them from the user experience. Measuring from the user experience is not simply probing the endpoint of your application to verify that the user can connect to it. Measuring them requires you to measure all layers of the stack, from how the application performs end to end, of course, but internally you may have to instrument things on how particular execution is going. In addition to that, when you own the machines, you also need to measure the underlying machines of the hosts. If you have physical equipment, measure the physical equipment as well. This is the full stack monitoring solution you have to have, every layer of your application. Now, there are lots of ways to monitor your solutions, and one of them is Dynatrace. And I'm going to bring her up on stage, one of the representatives from Dynatrace, to provide more context on how her application can deliver value to Service Fabric applications.
Thank you so much. Thank you, Alex. So as Alex mentioned, that you need to monitor your applications. When you monitor, you have to make sure that the monitoring solution you have is not just collecting telemetry for you, but it is also providing some intelligence on top of it. By the show of hands, does anybody know what Dynatrace is here? Anybody used it? Ooh, a lot of you guys. So as you know, we are not just a monitoring solution. We are the best in the APM space. Now we are moving over into software intelligence. So we not just collect metrics, we provide you with full stack visibility all across your applications, wherever they are hosted. For now, we have a great support with Service Fabric, so we will mostly be talking about how Dynatrace integrates with Service Fabric and how easy it is to monitor your applications which are running on the Service Fabric clusters. So what does Dynatrace provide you? Dynatrace typically provides you all the information. It collects telemetry, so full stack data view is available. All this is being picked up by the Dynatrace agent. We have an agent-based technology. It's called the Dynatrace One agent. It goes on your Service Fabric VMs. When it goes on your VMs, the way you can install it is using Azure CLI. You put it on the skill set. So all the cool features that Mikkel and Alex talked about, scaling up of nodes or scaling up of services, will work automatically once you install this extension. So once the extension goes on your VM skill sets, no matter whether you scale horizontally or you scale vertically, Dynatrace will be on it and it'll start monitoring all of those. I'll show you how that happens. But we have all metrics. We collect everything from your end user, your server level metrics, code level telemetry. All that data is collected. We have context around all that data. So we are not just collecting telemetry for you, but we are also providing relationships and context. So that makes our UI model extremely it differentiates it by providing that contextual relationships, and then it makes it extremely easy for us to tell you if there was a problem, where the problem was, and by what degree your application was going wrong. So we have all that available for you today. I'll show you a quick demo of how you can use Dynatrace. Okay, cool. So I have a very simple voting solution here. This is one of the applications that was designed by the Service Fabric team. It's a sample application that you would deploy on your Service Fabric cluster. So I have it right here. Now let's try and add something. So I'm voting against dogs, bunnies, and sloths. So let's see who wins here. I add a dog. So it was initially 125 votes if you were paying attention. Now it became 126 votes. Let's try and add bunnies. So it's at 109. Once we add this, it became 110. So you can see that it added immediately. Now let's add a sloth and see what happens. Okay, so it still didn't add. I wonder why. I would think that sloths are super slow, right? They're crawling all the way, coming in, they're still at 47. Now it became 48 votes. So the sloth took a really long time to crawl down into the voting list. Let's see what happened there. So let's go into the Dynatrace UI, and I will show you what happens when you install Dynatrace. So unlike Alex mentioned, I'm sorry, I don't have 5 nodes. I have only 3. But it's not a production cluster, so I hope I'm not underwater here. So Dynatrace I put the Dynatrace agent on this cluster. It has 3 nodes. You can see the interactions of how those nodes are connecting to each other. Dynatrace was able to figure this out once you install the agent. It also does the full stack monitoring for you. So we have the host, we have the data center, we have all the processes that you deploy. So if your services are scaling down, scaling up or down, whether it is auto scaling or you're manually going and scaling them, you don't have to monitor and add another monitoring solution. You don't have to monitor your monitor. Dynatrace takes care of that for you. So any applications you have will automatically be monitored. And then here, your code level is also monitored. So this is my voting web application. It's a web app which is making a call out to the data API that I have written. So it's kind of telling you that this web app makes a call to the data API. And if we go into the details, we'll be able to see, or Dynatrace can actually show you how that call is happening. So here, how we can see that the voting web app is actually making a call to the voting data app, and there's a proxy in the middle. How many times does it call it? And all your code level instrumentation is there without making any changes to your code. So it is profiling all of those relationships for you without having to go in and make a change. If we go back here, I can show you the request that we just did, the bunnies and the dogs that we just added. So it's real data. You can see here, it just happened like 2 minutes back when I was adding the dogs and the bunnies. So you're not missing out on anything. Dynatrace doesn't sample anything. It's all real-time data that keeps coming in. And if we go in here, you can see that the sloth took 10 seconds, and the dogs and the bunnies were in about milliseconds. So they were really very quick, but the sloth was really slow to come back. Now, why was it slow? You can drill down into it, and then Dynatrace will be able to show you the code level metrics, but most or any profiler can do that. So we'll see what differentiates Dynatrace. So we have something called problems, where if you go into today morning, I was playing with it. So I have a single problem where Dynatrace sets up thresholds. It automatically sets up thresholds, and when things go wrong or when there is an anomaly, it'll be able to tell you where the problem is and why did that happen. So here it is telling us that our voting web was super slow. Let's take a look at why it was slow. And when I drill down into these charts, you can see very clearly that there was an anomaly in the time frame. So that red bar on top is trying to gain your attention and tell you that there was an anomaly. Ideally, your application responds back really quickly, but during this time frame, something was going wrong. I wonder what it was. Let's see. When we analyze it, it gives you that there was a long lock time. So let's go into the details. We can see the hotspots where you can see that me, being a slacky coder, I added a sleep for 10 seconds so that the sloth can come up super slow and not jump like the bunnies. So all this code level instrumentation, your database queries, and everything else is going to be picked up for you without having to make any changes to your code. All you need to do is drop in an extension using the CLI on your virtual machine skill sets, and you get all this data for you. Yep, and scaling is not a problem. You can scale out and scale in. You can also see what the user was doing on the web server. So if I go in, I don't have a name here, but you can see my session and figure out that I, as a user, all of these are my sessions, and I was able to come in. I came in from Washington. I think this is Mikhail's laptop, so he's coming from Washington. and then all the things that you added, whether it failed, did it execute, and how long did it take. So all that data is going to be picked up for you automatically once you install the extension. And that is all I had. Thank you so much, gentlemen.
Thanks, Satya.
So the key takeaway for this portion of the talk is that you cannot get away with not monitoring and collecting telemetry on your services. How you achieve that, whether you use Dynatrace, whether you use Application Insights, is up to you. You just simply cannot get away with doing it. You cannot promise, you cannot deliver an SLA if you are not monitoring and not gathering telemetry. The telemetry is coming from Service Fabric. Rich telemetry can then be monitored and applied rules to it. That is going to make you successful. That is going to allow you to promise something to your customers.
So closing in at the end of this talk, there's a good time left. We're going to give you some time back at least. We hope that we showed you some tidbits and tips and tricks and stuff that you need to look after running Service Fabric in production. Got introduced a few new features that hopefully will help you run even more reliable and run better. And we hope you enjoyed this session. Please, we're going to stick around for questions. You can also use the microphones if you want to. There's not that many people in here, so just come up and we have time to address your questions up here.
Yeah, thank you. So I have an announcement to make. We have a booth here in the expo hall. You can come and talk to us. But we also we're doing an Xbox giveaway for all the people who attended the session. So my friend Tad here has some lead scanner. He can scan you guys, and then from one of you will win an Xbox from Dynatrace. We'll reach out to you.